Hello students, in this video I'm going to tell you how to use the data you got by counting the cells in the different phases of mitosis to figure out whether the duration of each of those phases is consistent with the reported duration of each of them in the literature. So to do this, you have to open up the Excel sheet for the chi-squared mitosis lab. In the observed number, you're going to type in the number of cells that you observed in each of the phases. So let's say that for interphase, we counted 429. In prophase, we counted approximately, let's say, 50. In metaphase, let's say that we saw about 10 in that phase, let's say 9 in anaphase, and let's say 7 in telophase. Then you're going to need to sum those up. So this is how you would do it. You could type in the equal sum, open parentheses B2 semicolon or colon B6 close parentheses, or you can type in equals sum open parentheses, and then select these numbers, and then press enter. All right, now to calculate the expected number, what you're going to do is you're going to multiply this number by the reported frequency. And I tell you in the background information what that is. So for interphase, it's 86.9%. So you would just have to type in equals B. And the reason I put the $ here is so that I can just drag it down and it'll stay B7 instead of going down as I drag it down. So I'll show you what happens if I just type in B7. You can see it selected that for me, and then multiply by 0.869. I press enter. If I drag this down now, you can see that this is all 0. The reason for that is that each time I drug it down, it drugged the B7 down with it. So it became B8 and B9. So to remedy this, what you need to do is put the $ here. And now when you drag it down, it keeps it all the same. And the reason it's all the same is because the fraction expected is the same. So you got to change that fraction expected. So for prophase, it's 10.4%, so 0.104. For metaphase, it is 0.015. For anaphase, it is 0.007. And for telophase, it's 0.005. Now I got to subtract the observed minus the expected. So I'm going to subtract this cell from this cell. So in this case, I'm just going to write equals B2 minus the C2. Press enter. And now I can drag this down. Now we got to square all of those cells. So this is just going to be equals. I'm going to select D2, and then I'm going to put the top hat symbol up 2 to square it, and that gives us that value. And then we're going to select all of these, and then finally we got to divide by the expected. So I'm going to type in equals E2 divided by the expected number was over here, that, press enter. And I'm going to do that for all of them. And ultimately, I need to sum that number up, equals sum of all of these. And I end up with a chi-squared value of 17.497 or 17.50 would be what I would round it to. All right. So now, how do I decide whether that is, how do I interpret that value? Well, I need to look at my degrees of freedom. So my degrees of freedom is going to be based on the number of categories minus 1. So I have 1, 2, 3, 4, 5 categories minus 1. And so 4 is my number of degrees of freedom. Now I look at this critical value, 9.488. 17.49 is greater than 9.488. So I'm going to reject the null hypothesis. The null hypothesis is that there is no difference between the observed and the expected. So with these values, I would say that there is actually a difference between what was observed and what was expected to be observed. And so I would reject the null hypothesis and say that there was something wonky going on with my onion root cell, and that that did not fit the observed frequency. All right, so that's how you do the chi-squared value and how you interpret it. I hope that was helpful, and I will talk to you later.